In my last video, I talked about sequences and series. And I mentioned in that video that there are different types of series. So, let's cover them today. There are 4 basic types of series that I'm going to cover today. The first type is called P-series. Now, P-series is basically just the series and 1 divided by n to the p, where p is some number. Integer to be more precise. Now, this series is actually very special, as depending on the value p takes, it can converge or diverge. Now that is something that will be talked about in my next video, convergence and divergence, and it is the single most important topic in all of the study of infinite series and sequences. Now, there are special cases of this. Now, one of them is the harmonic series, or 1 by n, where p is equal to 1. Now, this series, a hint is that this diverges, and the reason is very, very peculiar and actually very interesting. So this fact is quite important for one to know, is that for certain values, this can represent the Riemann zeta function, which is one of the most important concepts in all of math, but it is very complicated, so I'm not going to explain it today, and I really don't actually myself understand that much about this, but this can represent the zeta function for certain values, like 1 by n squared, which is, I really don't know how to draw the zeta function, so we're just gonna improvise, and we're gonna draw it like this. Yeah, I know this is not how you're supposed to draw it, but let's just say this is how you draw the Riemann zeta function, and this function is equal to pi squared over 6, and this is also a very interesting value, and there are more values. So that's the first type of series covered. The second type of series is a geometric series. This geometric series is a series that's equal to a times r to the n. Now, again, this is also very, very unique, and it's actually sort of related to the p-series. For if I have certain values of n, like certain values of n, like if I have negative terms for n, or if this is some sort of function of r, you can sort of get the first couple of terms overlapping with the p-series. But that's not a very important or useful connection, just a fun fact. Now, the biggest thing about these geometric series is they also, like the p-series, have very specific convergence and divergence rules, and there are hard set boundaries, and these are also one of the more effective ones in real life. Now, not really popular, but one example that is very useful in understanding how geometric series would be used is this example that would come from physics. So, we have a ball over here that is above the ground at a height a. It goes to the ground and bounces up. Now, this height is a height r times a, where r is less than 1, and of course greater than 0. And this continues on and on until infinity, basically, until it reaches the ground, and the goal is to kind of find how much distance it traveled, etc., or the velocity and stuff. Now, this, as you can see, is clearly just representing a geometric series, a plus ar plus ar squared, and so on, and you kind of see that this would converge, and this forms the basis of the whole argument about geometric series. Now, if you notice that in these examples, I'm not actually giving too much info, a lot of info. I'm giving a lot of basic and essential information to understand the series, but I'm not actually giving too much info. That's because most of the info that comes in infinite series is about how they converge or diverge. Now, those are the first two types of basic series explained. Let's move on to the third type. Now, the third type is alternating series. Basically, we have -1 to the power of n times some function of n. Now, this function of n could really be anything. This function of n could be essentially a p-series. It could be a geometric series. It could be a polynomial. It could be anything. But the thing that makes this special is this first term over here, -1 to the n. Now, to be precise, this doesn't always have to be n. It doesn't actually have to be n. It can be like n plus 1, but the biggest thing is that there is a function or a kind of thing with n and the n in the actual exponent, and normally it will have linear terms, but sometimes it changes. Now, what does this do to the series? This basically makes it f of some value n1, then minus f of some value n2, or it could be the other way, it doesn't really matter. But the whole point is that the sum of the entire series goes like this. You have positive, negative, positive, negative, positive, negative, and sometimes these proportions might blow out higher and higher, but other times they might get lower and lower and lower and lower until they're basically zero, and it just completely depends. The biggest thing is you have a positive component, but you also have a negative component that is below the axis. So that's what makes alternating series so unique. And they're actually a very big part of studying infinite series, as these also are very useful in things like sine waves, etc., etc. Now, those are 3 of the 4 types of basic series that I'm going to cover in this video done. But we still have one more type. Let's look at it. The telescoping series is a very, very interesting series, and in fact, one of my most favorite series to do, as just how simply satisfying they are to solve. Now, the basic idea is you would have some function of n plus then some function of n plus 1. Okay, no, not plus, sorry. Minus some function of n plus 1. Now, let's say as n goes from 0 to infinity, then you would get f of 0 minus f of 1, and then plus f of 1 minus f of 2, and so on. And now you see that the f1 cancels out, the f2 will cancel out, and the only thing that's left is this f0 term, and that is the value of the series, and that's what makes it so unique. There's so many terms, and the function can be as complicated as possible, but just by basically telescoping, as it's called, or just canceling out a bunch of terms, you get a very, very simple answer, and that's why I said they're very unique in the way, like with these series, there would be some sort of formula or like some sort of other things that you have to memorize. For this one, you can literally just plug and chug or just evaluate one single term without really having to know anything else, and I find it really, really satisfying. So that's about it for this video. I really hope you did learn something from it, and as always, keep on learning stuff. So thank you so much. See you in the next one, and bye-bye.